Thank you for joining this lesson. We're going to discuss vector 2, the proportional division of a line. Given that vector OA equals to 3i plus 2j minus 4k, and vector OB equals to 4i plus 5j minus 2k, and that P divides AB in the ratio 3:2, determine the position vector of P in terms of I, J, and K. So what we're going to have here, I'm going to sketch the positions of A, B, and P, and for A and B to be divided by P, it means they are all collinear. Therefore, I'm going to consider a triangle from the origin. If this is point OO, then we have from O to A. Again, we have from A or from O to B. Yeah, let me have it like this. This is going to be our B. Then now P is an external divider. So it is not between A and B. It is an external divider. So what we are having here is the position vector of A, which is 3i 2j minus 4k. So the coordinates without the unit vectors are going to be 3, 2, -4. Then on the other side, we are also given B as 4, 5, -2. That is when we write it as a column vector without the unit vectors. Now it is P which is unknown, and we will give it X, Y, and Z. That is the unknown. Now it should be noted that when the divider is external, like in this case, the ratio is given a negative, that means it is an external divider. So from A to where P is, we have 3 divisions. Then from P to where B is, backwards now, due to the negative sign, 2 divisions. So we have from A to P, 3 divisions. And from P back to B, we have 2 divisions. So we have 2 divisions here. And now that we had 3 divisions up to P, it means we have remained with only 1 division. So now, the ratio at which B divides AP is going to be 1:2. According to the ratio theorem of dividing vectors, it should be noted that if we let this one be M and the ratio here be N, then mathematically, for us to get the coordinates, let me give the formula according to the ratio theorem. For us to get the coordinates of B, which is at the center, we need the ratio, the proportions on this side, which is M, divided by the total proportions, M plus N, and we multiply with the vector P, now that we've used M as the numerator. Then we add, we take the other proportion, which is N, divided by M plus N. Then we multiply with the opposite vector, which is going to be A. So this is how the coordinates of B, the point at the center, are going to be given. So now that the ratios are provided, we're going to say that B, which is 4, 5, -2, equals to, we start with 1, divided by the total, which is 3, the vector P, which is unknown, so X, Y, Z. Then we add the other proportion, which is 2, divided by the total 3, multiplied, now that we've used 2, the opposite, which is 3, 2, -4. Yeah, 3 to -4. Then now we proceed to calculate the unknown. So we're going to say A, okay, we can equate the X components, whereby we'll start with 4 being equal to 1/3 X plus 2/3 times 3. This is going to give us 2. Therefore, when we take 2 to this side, we shall have it as 2 equals to a third x. To remain with x, we multiply by 3 through, and this gives us x as 6. The next, we equate the y components. 5 is equivalent to a third y plus 2/3 of 2, which is going to be 4 out of 3. So that will remain with a third y on one side. Then we will need to take 5 and we subtract 4 out of 3. This gives us 3 and 2/3. Then now to remain with y, we need to multiply by 3 because this is a third, and also by 3 on the other side. So times 3. This gives us exactly 11. Then finally, we need to solve the z components, whereby we're going to equate -2 with a third z plus 2 out of 3 -4. That will be -8 out of 3. Being taken to the other side, it will be added, so that we have -2 plus 8 out of 3. This will be 2/3 equals to a third z. So a third can simplify from both sides, and z is going to be equivalent to 2. Therefore, now with x, y, and z, then the position vector of P is going to be 6i plus 11j plus 2k. So that is the position vector of P in terms of I, j, and k.